Welcome to the video tutorials of mechanisms by mekanizmalar. The venturi effect was described scientifically by Giovanni Battista Venturi. He stated that fluids under pressure passing through converging pipes gain speed and lose head and vice versa for diverging pipes. Venturi was a very bright man. His ingenuity can be understood when he's describing the venturi effect and stating that fluid is under pressure. This means that there should be a pressure difference in the pipe for the fluid to flow. Most of the videos on the internet explain the venturi effect by using Bernoulli's famous equation seen here. By using this formula we can show that the pressure at the point P2 is less than the pressure at the point P1. Furthermore, we can prove that pressure at the point P3 is equal to pressure at the point P1. This creates a problem, which is the lack of pressure gradient between points P1 and P3. This is because Bernoulli's equation is driven by assuming inviscid uncompressible flow by using only conservation of energy and conservation of mass. However, in nature there is not such a thing as inviscid and uncompressible flow. If we take into account viscosity alone, however, we end up with very complex equations. The simplicity of the Bernoulli equation allows us to calculate the flow speed in the pipes by just measuring the pressure drop in converging-diverging nozzles. With the use of U-tube manometers shown here, we can measure pressure difference between point P3 and point P2. This pressure difference will be also equal to pressure difference in between point P1 and point P2. From here we can calculate the flow rate of fluid flowing in the pipe. Notice how the pressure differs between the 2 points when we increase the flow speed or vice versa. Clemens Herschel was the first man to put the venturi principle in his flow meter invention. He named his invention the venturi meter out of respect to Venturi's 1797 experiments on the subject. If he named his invention the Herschel meter, Venturi's name would be a small footnote in scientific books. We should be thankful to Clemens Herschel for his modesty. Herschel was awarded the Ario Crescent Gold Medal of the Franklin Institute of Pennsylvania for his venturi meter in 1889. By using this flow meter you can measure the flow rate passing from very small tubes as shown in here, or to very large pipes shown in here. Notice the worker's size with compared to venturi meter. Indeed, millions of venturi flow meters, small and large, are being used in all over the world. Devices made by using Venturi's principles are extremely reliable, because they have no moving parts. They are extremely simple to build and very useful for so many applications. Flow meters, carburetors, steam injectors, sprays are few examples of many. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to my channel and hit the like button. We appreciate your support.